Hello everyone, welcome to our YouTube channel. Today we'll be discussing about laws of chemical combinations. There are 5 main laws of chemical combination. First one is law of conservation of mass. Second is law of definite proportions, or also known as law of constant proportions. Third is law of multiple proportion. Fourth one is Gaseous law of gaseous volumes. And fifth one is Avogadro's law. So we'll study each law in detail. First law is law of conservation of mass. This law is proposed by Anthony Lavoisier. So what he says is, mass is neither created nor destroyed during chemical or physical reaction. That means total mass of the reactants will be equal to mass of the products. In order to understand this law, we will take one example. When wood burns, it combines with oxygen and changes not only to ashes but also smoke. Suppose you had measured the mass of the wood before it burned and mass of the ashes after it burned, and also suppose you had been able to measure the oxygen used by the fire and the gases produced by the fire, what would you find? Here the total mass of the reactants will be equal to mass of the products. That is 30 kg of log and 1 kg of fire, it gives 31. Similarly, ashes and smoke gives 28 kg plus 3 kg, that is 31 kg. That is, total mass of the reactants will be equal to total mass of the products. So here law of conservation is satisfied. That is, mass is neither created nor be destroyed in a chemical reaction. Now we see another example of hydrogen and chlorine gives HCl. Here hydrogen is 2 grams and 71 grams of chlorine we have taken. So the mass of the reactants is 73 and the mass of the products is 73. That means total mass of the reactants and the mass of the products are same. So this is the law of conservation of mass. Mass is neither created nor be destroyed in a chemical reaction. Now we move on to the second law, that is law of definite proportion, also known as law of constant proportion. This is proposed by Joseph Proust, and it states that in a chemical compound, the elements are always present in a definite proportion by mass, or in definite ratio, or we can say it is in a constant ratio. So we'll understand this law with an example. For example, if you take ammonia, the formula is NH3. N nitrogen and H is hydrogen. So 3 molecules of hydrogen are there. So if you measure the masses of this NH3, mass of nitrogen is 14 atomic mass unit and mass of hydrogen is 1. For 3 hydrogens it will be 3 atomic mass unit. Now if you measure the ratio of these elements, we can see it is 14:3. That is, it is in fixed proportion. So what this law says? In a chemical compound, for example ammonia, the elements, that is nitrogen and hydrogen, are present in a definite proportion or constant proportion by mass. Constant proportion means it won't change. So the ratio of masses of nitrogen and hydrogen is 14:3. Now we move on to the next law. It is law of multiple proportion. This law is proposed by John Dalton. This law states that if 2 elements form more than a single compound, the masses of one element combined with the fixed mass of the second are in the ratio of small whole numbers. This will explain with an example. If 2 elements, for example carbon and oxygen, gives more than a single compound, it can give carbon monoxide and carbon dioxide. Now if you take the carbon monoxide, the mass of carbon in carbon monoxide is 12 grams, mass of oxygen in carbon monoxide is 16. Now we take the next one, mass of carbon in carbon dioxide is 12 grams, mass of oxygen in carbon dioxide is 32. That means 2 oxygen molecules are there, so 2 into 16 becomes 32. Now what does the law says? When 2 elements combine to give more than one compound, that is carbon monoxide and carbon dioxide here, the masses of one of the element with the fixed mass of the other element. Which is the fixed mass over here? Carbon's mass is fixed, 12 grams. with the fixed mass of the other element bears a simple whole number ratio. Now, if you take the ratio of oxygen in carbon dioxide to oxygen in carbon monoxide, it will be 2:1. So, this is the law of multiple proportion. Now, the next law is Gaseous law of gaseous volumes. Gaseous law states that when gases combine or are produced in a chemical reaction, they do so in a simple ratio by volume, provided all gases are at same temperature and pressure. Here the condition is that gases should be at same temperature and pressure. Here the volumes of gases are represented in simple whole number ratio. Now we'll look into one example. Here, 2 volumes of hydrogen combines with 1 volume of oxygen to give 2 volumes of water. So what does the law says? When gases combine or produced in a reaction, they do so in a simple whole number ratio by volume, provided all gases are at same temperature and pressure. So here the volume is in the ratio 2:1. This is Gaseous law of gaseous volumes. Now we move on to the next law, that is Avogadro's law. It states that equal volumes of all gases at the same temperature and pressure should contain equal number of molecules. Now we'll take one example. See, there are 3 balloons over here. One balloon is filled with hydrogen, second balloon is filled with nitrogen, and third balloon is filled with oxygen. These balloons all have same volume. So what is according to Avogadro's law? Equal volumes of all gases under same condition of temperature and pressure contain equal number of molecules. So the number of molecules in hydrogen will be equal to number of molecules of nitrogen will be equal to number of molecules in oxygen. So this is Avogadro's law. So we have studied 5 laws. Hope you have understood. Thank you for watching. We'll meet you in the next video.